Hi everyone. This video is part of my Docker deployment series. In this video, we will use Docker Machine to deploy the example voting app, and we will do this on AWS Cloud, Google Cloud, as well as Azure. So I have put the steps in the GitHub. This is the sample link to that. So here we can find the AWS, and similarly I have created separated pages for Azure and Google Cloud. So broadly there are around 4 to 5 steps. The first step would be creating the master and worker nodes. So the only difference would be the type of driver that we mentioned based on the type of cloud. The step 2 would be to add the username to the Docker group. This allows execution of Docker commands without the root access. The third step would be creating the swarm cluster, and the fourth step would be deploying the application. In the case of AWS, we need to expose some of the swarm mode ports so that the nodes can talk to each other, as well as the ports that we are going to access from the outside world for the application itself. So this is not needed in Azure as well as Google Cloud because of the way in which they create the virtual network. And the last step would be accessing the application itself. So this is the steps that is needed for to create the cluster for the AWS Cloud. So similarly, I have the steps here listed for Azure as well as the Google Cloud. So to save time, I've already created the cluster on all the 3 clouds. So if you do the Docker Machine ls, we should be able to see the clusters created. So basically I have 2 nodes, which is master 1 and worker 1 on Amazon Cloud, and similarly on Azure as well as the Google Cloud, and that's the Docker Machine ls lists these output. So for more details on how we can use the Docker Machine and all the options, we can reference these web pages. We have separate ones from Docker documentation for AWS, Azure, as well as the Google Cloud. So here it gives a lot of options in terms of what instance type to choose, what security group, what VPC type to choose. So if you don't give most of the options, the default options are chosen. And now that we have created the nodes itself, we can log into the each of the clouds and check that the nodes got created. So when the nodes get created, along with the creation of the VMs, the Docker also gets installed in the node. Usually the latest version of Docker gets installed. So here we are seeing the the 2 nodes created in the case of AWS. So similarly, in the case of Azure, we can see the master and the worker nodes here, as well as in the Google Cloud we see the same. So here I have logged into the master and the worker nodes in the AWS Docker Machine. So as we mentioned earlier, one of the first steps to do is add the user, in this case Ubuntu user, to the Docker group. This allows us to perform operations without needing root access. So once we added the Ubuntu to the Docker group, we can log in again, and we can check what version of Docker is running. So it's running the 1703 version. So at this point we are ready to create the swarm cluster. It's very easy to do that. All we need is on the master node, we need to do the Docker swarm init, and so it tells what are the options if we have to create a new worker node. So we just copy this with the keys into the worker, and so the reason I got permission denied is because after I added user Ubuntu to Docker, I did not log out and log back in. So now I have logged out and logged back in, and now we can try to add the keys again. Okay, now the node joined the swarm as a worker. Now we can see that there is a 2-node cluster with one master node and one worker node. So I have created the swarm cluster on Azure Cloud as well as Google Cloud. So we can check that. So we need to execute this in the master node with the swarm commands. So we can see the cluster in the Azure Cloud. We can do the same in Google Cloud and we can see the same. The one thing I want to point out is in the case of AWS, we need to open up some extra ports for the swarm to work. So here we can see that what are the extra ports that is needed. So some of these ports are needed for swarm communication, like the 2377 as well as the 7946 and 4789. And the other ports 8080 and 5000 and 5001, this is needed for the voting application. So I have opened up. So these 3 ports are, we need to open it up for all the clouds, but the swarm communication is only needed in the internal network, and that is needed only in the case of AWS. We are ready to deploy the app. I've already, in my host machine, I've already cloned the voting application. So first we can set the environment to the master node, and then we can deploy the application. So here we have set the environment to the master 1, and now Docker stack deploy, we are creating the complete application here. So let's quickly look at how the application itself looks like. So basically there are these basically services, which is the Redis, the DB, the vote service, the result, and the worker, the visualizer service. And some of these services are exposing the ports for external world, and some of them are using for internal communication. And now the stack is deployed, we can look at what is the status of the stack. So this is the vote stack that we have deployed, and we can check what is the status of this particular stack. So this should show us what are all the different services that are part of it, and how many replicas that this particular service has. For some of the services, we have said the replicas to be more than one. For example, in this case, the vote application has 2 copies, one which is running on the master and the another which is running on the worker. And basically the load balancer would automatically take care of load balancing between the 2. So now that we have successfully deployed the application, we can see all these services are in the running state. Let's see if we can access the application from the external world. For that, let's first go to the AWS cloud, and here since the services are deployed using a routing mesh, we can access these services from either the master node or the worker node public IP. So in this case, let's pick the public IP here. So we have 3 services. The first one is the visualizer, which is running on port 8080. Then we have the vote application, which is running on port 5000. And then we have the result of the voting, which is running on 5001. So the visualizer shows what are the different nodes and what are the different services that are running. It's a nice way to see the complete picture. So here we can see that this is a service running, and note one interesting thing here, which shows the container ID. Now if we do the refresh, since the voting service contains 2 containers, automatically it gets load balance between the 2 containers. And finally, this is the result page itself. And so we can do the same in the case of Google Cloud as well as the Azure, and we would see something exactly similar. Thanks for watching.